Okay, yeah, I have started recording.
Yes. So just one more question.
Yeah.
So when that VLAN 112 subnet is shared by the EVPN route towards VTEP A, is that shared by type 5 route?
Okay. So we will see that, right? You mean to say how
Okay.
we generate this route, correct?
Yes, yes.
Yes. So we will discuss that how we will generate this route. In fact, we will also, there are two routes what we will generate out of this. So in symmetric, right? It will be like this. So it will be, so one route is for full subnet, okay, /24, and another will be /32 route for your last host 4, that is 11/32. Okay, so these are the two routes we will generate, right, based on type 2 and type 5 both. Okay, but that we will discuss, but this is how it will, you know, it will generate. Any other question? Is it clear about why, we need to use particular verb, right? Verb, common verb, which is nothing but map to VNI and VLAN, specific dynamic. It will create dynamic VLAN, and through which you can route the traffic, right, from one VLAN to another VLAN. Is it clear? Any question on this, about this concept?
Sorry, one more question. So on the VTEP 2, suppose if we have VLAN 13 and VLAN 13 has to uh, communicate to VLAN 11 on VTEP 1.
Mhm.
So so now how would the route look like? Like
Okay, so let's say here on VTEP 2, right? VTEP 2 VLAN 13 is there, and this guy has to communicate with VLAN 11, right? And
uh-huh.
we have host here for VTEP VLAN 13. Let's say at 3, right? 13, 13, 11. Okay. It same, right? See, basically you have one dynamic VLAN 20 common. So what you will do? From VLAN 11 packet will come, you will route it into this WRF A, right? Which is dynamic VLAN. And you send that packet with this VNI 2000, right? VNI 2000. When you receive this packet based on VNI, you will understand that, hey, this packet belongs to this WRF, right? So this WRF A. So you will put that, basically route that packet or land that packet into WRF A. Now on WRF A, you will check, hey, I want to send packet to 13, 13, 13, 11, and you already have SVI for it. You will check the ARP for that and forward that packet, right? So it seems through one single VLAN, common VLAN, you can route packet between any VLANs here, right? Even though it's 14.
Okay.
Yeah.
Just so in the above route, that MAC B, is that the router map?
Okay. Yes. So yeah, we will discuss on that. Yes, it is router MAC, this MAC, which is next hop
Okay.
MAC. Okay. So we will discuss
Okay.
this. Why this?
Got it. Got
Okay.
it.
Yeah. Okay. So now let's consider one more VTAP, right? There is one more VTAP 3. Okay. And here you have 14 VLAN 14 and 14.14.11, right? So what you will have common is WRF A. So you have WRF A common, right? You have configured WRF A to VNI 2000, right? So that you have configured. So what will happen is from here, right, it will route the packet into VLAN 14, send it here into this WRF, and then it will again routed and will be sent out to the host, right, in 14 VLAN, right? Obviously, all this should be in WRF A. This VLAN 14 also should be under WRF A. Okay, is it clear? So basically, in symmetric IRB, you have a common WRF, right, across all the VTAPs, which is nothing but dynamic VLAN, common dynamic VLAN or VNI, through which you will transit your packet. Okay. Is it clear? Any question?
So for one VRF, we need one transit VNF.
Yes, you can say that
So,
right
okay.
now. Yes. Okay. We also can have basically symmetric IRB. It's not that we need to use specific WRF, right? You can also have default WRF and you can use it. So that also is there available possible, right? But yeah, so for that you have different config and yeah. But generally customer uses this way that they will have one common WRF and through which you will transit the traffic. Okay, so if is there any other question? Okay, so let's move to the presentation, right? Okay, yeah, so before that I want to also why it is called symmetric IRB, right? Can anyone tell me why it is called symmetric IRB? Hello?
Uh, because the
we
VLANs are matched,
Sorry?
because it has symmetric VLANs in both the devices.
No, see, basically it's not symmetric, right? This is basically it's here, it's VLAN 11, here it's VLAN 12 and 13, right? Different VLANs. Okay, so see, basically what it does is when you send packet from H1 to H4, right? What it will do is you send packet to the H1, right? H1 will route the packet from VLAN 11 to whatever dynamic VLAN 20 or WRF, right? So your routing happens here between H1 to this WRF, basically WRF or dynamic VLAN. Then you send the packet again, it will have VLAN 20 dynamic VLAN to VLAN 12, right? And then send the packet. Okay. When H4 reply the packet, again, same happens, right? On same device. So again, when H4 sends the packet to the gateway of VLAN 12, it will do reverse routing, right? At on VTAP 2. And when it receives here, again, it will do routing from VLAN dynamic VLAN 20 to 11. So basically it is following symmetric routing. Routing is symmetric, right? For forward traffic, you did routing from 11 to dynamic VLAN or WRF A here. And so when packet comes back again, you will do the same routing, right? 20 to 11. So basically your routing VTAP is same, right? Symmetric. It's not going to change. But if we discuss about asymmetric IRB, you have VLAN 11 and 12 on both sides, right? VLAN 11 and 12. All SVI everywhere, right? So here also you have VLAN 11. Then what will happen when you send packet from one host to another? You do routing here from VLAN 11 to 12, right? 11 to 12 and bridge the packet directly. For reverse traffic, you do VLAN 12 to 11 here routing, 12 to 11 here routing, right? And then bridge the packet. What does that mean? Your routing for forward path, it happens on one VTAP, and for reverse path, it happens on another VTAP. That's why it is called asymmetric routing, right? Not routing is not on same device every time, right? So that's why it is called asymmetric routing. But in this case, because always your routing will happen here for forward and reverse path and same for here, that's why this is called reverse symmetric IRB. Okay, is it clear?
yes,
Okay.
yeah.
Okay. Okay, so let's So VTAP is only configured with subnet that are present on directly attached host, right? So you will not have all the SVI present on all the VTAPs, right? You will have only SVIs which has host under that VTAP, right? That subnet. And connectivity between two VTAP or two SVIs will be established through IPv4, right? So basically ingress VTAP routes the traffic between local subnet or local SVI to IPv4 VLAN, right? Or dynamic VLAN. And then at the other end, that dynamic VLAN to destination subnet or destination VLAN, it will be routed, right? And that's why this is called symmetric IRB, because your routing will remain on same device for forward and reverse path. Okay. So let's discuss based on this topology, right? So basically you have this VLAN 100, right? And the gateway is here for IRB, or SVI for VLAN 100 is here. Other side you have VLAN 200, right? And SVI for VLAN 200 is in this side. And this host is in VLAN 200. This guy is in VLAN 100. Now what you will configure is you will configure common VRF, L3 VRF or IP VRF, right? We can name it as A, VRF A, right? VRF A. And obviously with VRF A, you will assign common VNI, both ends, same VNI. And you will also have dynamic VLAN generated because of that, right? Dynamic VLAN. And through this common VRF, you will forward the packet, right? So what will happen? Your host will send the packet to the gateway, SVI 100. Now you check the destination IP, that is 2.2.2.3. You will have route here for destination IP, which is 2.2.2.3, right? /32 or for subnet as well. And it will tell that, hey, to send this packet, you have to send this packet to this VTAP, VTAP2, right? And the MAC address. Okay. We'll come to this MAC address part. But yeah, you will have this route installed by using type 2 route. We'll see that as well, right? Type 2 route and type 5 is also in play here. But yeah, this /32 is because of type 2 route, and you will forward that packet. So basically what you will do is this packet you will receive and forward it into this VRF, right? Basically you will forward that, route that packet from this VLAN 100 to this VRF A and this VNI or dynamic VLAN, forward that packet here. Again, as you based on VNI, this particular VNI 111, this guy will understand that this VNI is mapped to VRF A. So it will land the packet into this VRF A. And from there, it will check the destination IP, which is in VLAN 200. It will route the packet into 200 and forward that based on R. Okay. So this is how this, overall this will work. Okay. Any question? Okay. So now one point here, right? Okay, let's maybe we can discuss that in next one, I think. Okay, so basically the one advantage here, if you see, right, basically what you do is when you have to send packet to 2223, right, or any other host, are you learning MAC address of this host here on this SVI? Basically on this device, sorry, on this VTAP, are you learning MAC address of this 2223? Let's say MAC is H2. Are you learning MAC H2 on this VTAP?
No,
No. Why?
because we are not, we are actually sending it through the different VLAN, that
Correct.
another route.
Right. And as you know, in fact, this SVI or this VLAN is not even present here, right? This VLAN 200 is not present at all here, right? Correct. So basically, you don't have VLAN present here. Obviously, you will not learn MAC. And also, because you have to route the packet, you are not bridging the packet from here, right? You have to route the packet to another VTAP, right? So that's why you don't need to learn MAC address of H2 on this VTAP, correct? So what you are doing is from 100, you are routing packet. You are basically checking the routing table, right? And you will find that, hey, to send packet to this subnet, I have to send packet to this VTAP, right? This IP address, VTAP IP address, which can be 2.2.2.2. So when you send this packet, you have to send packet to 2.2.2.2. You need to know MAC address of this guy, but not the end host MAC address, right? Correct. So basically, you need to know the MAC address of this and forward the packet here. And from there, again, when you route the packet into this VLAN 200, during that time, you need to know the MAC address, right? How to send packet to H2 from which interface. And based on that, you will forward that packet out, right? So basically, do not need to learn MAC address here on VTAP 1, right? For H2. Is it clear? Any question? Okay. Is it clear? Anyone has any question? Okay. So basically, you do not need to learn the MAC address. If we want to discuss this through our diagram, right? Let's consider without VTAP, right? Normal. So what you will have? Let's say you have VLAN 11 and 12 both here, right? Okay. Forget about VTAP. It's normal route, normal L3 switch. Okay. Normal L3 switch. What you will do? So you will send packet. H1 will send packet to the gateway. H1 will send packet to the gateway in VLAN 11, right? It will check the destination IP, right? Which is 12.12.12.11. It will consult the routing table that, hey, for 12.12.12, so because it is directly connected subnet, so you will have IP route that 12.12.12.0 is directly connected, right? /24 directly connected on VLAN 12, right? Directly connected. So what you will do is you will route the packet from 11 to 12, right? And now you have to bridge the packet. You have to directly send packet to the host, right? So what you will do? Now you have to check the packet destination IP is 12.12.11. So you have to check that ARP, right? ARP for 12.12.12.11, right? 12.11 and whatever the MAC address associated with it. So now you understand that, hey, I have to build the packet, right? To send it here. So when I send packet from here to gateway, my source MAC was H1 and destination MAC was gateway MAC, right? Gateway MAC, which was here. Okay. Now, when I have to forward this packet to this guy, my source MAC will be, what will be my source MAC? Okay, let's take proper. Hello.
Yes, we can.
Okay, yeah. Because my internet is not stable. Okay, so can you tell me when H1 sends the packet to the gateway, right? It's a normal switching. Okay. So when H1 sends the packet to the gateway, what is the source MAC? H1, right?
H1, yeah.
And what is the destination MAC?
Okay.
Gateway MAC, let's say R1, right? It's R1. And what is the source IP? ICMP packet, right?
11.10.
11.10 and destination IP 11 dot sorry 12.11, right?
12.11.
Okay, so now you send the packet here. Now what you will do is you will check the destination IP. Okay, you will check destination MAC. It's my MAC. Basically I have to route this packet. Destination IP is 12.11. You consult the routing table. You find that, hey, I have local route available, right? It is directly connected subnet. So now you will
Yes.
check the destination IP, right? It is 12.11. So basically you have to send packet to this guy, right? So what you will do is you will check the ARP table that, hey, 12.11, what is the MAC address? Because I want to send packet to this, right? And based on ARP table, you know that MAC is H4. Okay. So ARP is there. So basically you have ARP, right? Learned here for 12.11. And what is that MAC is H4. Okay. So what you will do now, what changes will be there in this packet when this packet you are going to forward, right? So this to this, right? So what you will do is you will route the packet from 11 to 12 and then forward it directly to H4, right? So what will be the source MAC, destination MAC? Is there any change in this?
The source MAC would be the R1.
R1,
Destination MAC would be H4.
H4, right?
Yes.
Any change in source IP and destination IP?
No.
No. Everyone else is agrees with this, or anyone has any
I
different?
think because when like this would be for asymmetric, right? Symmetric, I think destination MAC has to be router 2 because it
Yeah,
will route from the
yeah. So that we will come to. We'll change that and we'll discuss on that. But what about this?
yeah. So isn't the destination MAC R2? Because then we have to route from that common VLAN to
Yes.
back to VLAN 12.
Yeah. So we'll discuss that. We'll come to that.
Oh, okay, we're not up to that. Okay.
Yeah,
No,
yeah.
sorry.
Right now, let's discuss this, right? Where you have both SVIs present.
Oh,
So
okay.
is this correct, right? Is this right? Is there any change on this? Anyone has any different thought? No, right? Okay. So now, okay, now let's take, right, that we don't have basically VLAN 12 here, right? A symmetric IRB. Again, we are talking normal without VXLAN, okay? But we have common VLAN, right, between these two, right? So we have common VLAN. So we have common VLAN between these two, okay? Now what will happen?
Now we need the route, right?
Yeah.
Or
Right. So
now
let's go one by one, right? So H1 will send packet to the gateway, right? So this is the packet, right?
this should be same.
Same, right? Now what you will do is you will again check that, hey, destination MAC is my MAC, destination IP is 12.11, right? Okay. So now you will check that, hey, what is the route for 12.12 subnet, correct? And
Yeah.
the route for 12 subnet is 13.13.13.2, correct?
Yeah. Yes.
So basically now you have to send packet to, so basically you will route the packet from VLAN 11 to 13, right? and forward this packet. You have to forward this packet to this guy, right?
Yeah.
Next hop, 13.2. Now, can you tell me what will be, will there any change in this source MAC, destination MAC?
The destination MAC now would be the R2.
R2. And source MAC is?
That will be the same.
R1, right?
Yeah.
Okay. Everyone agrees with this. Kamil also was going to say same thing, right? Mentioning same. So anyone else has this any change difference, or if you have not got this? Everyone is agree with this? Okay. So I understand that, everyone is in sync with this. Okay. So now I want to basically my question is, have you learned this H4 MAC here in MAC table? H4, do you have to learn to forward the packet to H4? Do you have to learn H4 MAC or basically populate MAC address of H4?
No, Professor.
No, right? Or if let's say there are any other hosts, right? H2, H3, H5. Do you really need to learn MAC of all this host here?
No.
No, right? To forward the packet to this host, what really you need to learn in MAC address table, or you need to know is this next hop MAC table, right? Only next hop MAC table. As far as you know that if I want to send packet to this guy 13.2 and MAC address for that 13.2 is this R2, I'm fine, right? I don't need to learn this MAC addresses of all the hosts which are in this different VLAN 12 behind this other VTAP. Agree, right? So basically, same is for okay. So this is how, basically in asymmetric, symmetric IRB, you don't need to learn all the MAC addresses for which you are not VLAN, right? Or which is not under your VLAN, right? You don't have to learn that MAC addresses, right? So basically, however, if you remember in asymmetric IRB or the one where you have VLAN 11 and VLAN 12 both present, right? On this VTAP VLAN 12, SVI present on this, you need to learn ARP, right? You need to learn ARP for your end host, and you need to learn MAC address for your end host, right? So basically you need to have R for H2, H4, H5, everyone to understand, because you are routing and you are routing to that VLAN 12, and then you have to bridge that, right? So you need to know the ARP and MAC to send that packet out, right? For that VLAN 12. So basically, as we discussed, right, that in asymmetric IRB, you have to learn all the MAC addresses behind all the VTAPs for all the VLANs or SVIs, right? You need to learn ARP and MAC addresses so that you can bridge the traffic directly. But with symmetric IRB, because there is intermediate VLAN through which you are going to send the traffic, you do not need to learn ARP or MAC of this host, right? Unless and until you have that VLAN present here. Okay, VLAN 12. Then only you have to learn, but otherwise you don't need to. Is this clear? Is it clear, or you want me to repeat it again?
Good for me.
Okay. So yeah, that's the advantage of symmetric IRB, right? That you don't need to learn the MAC address. And similarly, you don't have to configure VLAN to VNI mapping also for the VLAN, which is not present to your VTAP, right? So if you don't have VLAN SVI for VLAN 200 present, right, on this VTAP, you don't have to configure VLAN to VNI mapping for this VLAN 200, right? On this VTAP. That's not needed. What you need is this VRF to VNI mapping, okay, which is common, both end. But if there are VLAN 300 here, right, 400 here, you don't need to configure VLAN to VNI mapping for 300 and 400. You just need to configure VLAN to VNI mapping for your local VLANs, SVIs, which is 100, right? So basically, there were two limitations in asymmetric, that is exhaustion of ARP table, explosion of ARP table, or even MAC table, right? MAC table. And also VLAN to VNI scale, right? We have to configure all VLAN to VNI, all SVI VLAN to VNI mapping on all the VTAP, because all SVI is present everywhere, which is not the case with this, right? So basically, yeah, you don't have to also configure all the VLAN to VNI mapping. So these are the two problems which will be solved by using symmetric IRP. Okay. So now let's go into more detail, right? Basically, let's configure its combination of your topology, or customer topology is combination of symmetric and asymmetric, right? What does that mean? It is possible that some VTAP has some SVIs, SVI 100 and 200, but some VTAP has 100, this guy has 100 and 300, right? So basically mix and match. So some SVIs are common between two VTAPs and some are not common, right? Then how this will work, right? How this will work. So let's understand by using this diagram. Let's say you want to communicate between same VLAN host. This host is in VLAN 100, right? H1. And here H2 is also in same VLAN 100, H2, same subnet. What will happen? H1 will, send packet, right? In VLAN 100. What you have to do is basically through type 2 route, EVPN type 2 route, as soon as you H2 sends the packet, or basically H1 sends out packet ARP request directly for host H2, right? So what you will do is you will forward that packet, flood that packet to this guy, right? And you learn the MAC address directly for this VLAN. And basically you will just bridge the packet, right? Through this VNI 100, correct? VNI 100. So H1 to H2 directly in same VLAN. It will be bridge the traffic, correct? Now let's see that there is host H1 is in VLAN 100, right? H1 is in VLAN 100 and H2 is in VLAN 200, different subnet. What will happen is H1 sends the packet to its gateway, right? VLAN 100. Destination is 200. So it will check the route for 200 VLAN subnet, right? Route. And it finds that, hey, it is locally connected. It is already there. SVI is there, right? Then it sends out ARP request, get the reply MAC address, and then it will bridge the packet into this VNI 200, right? So in first case, when it was same VLAN, it will just use the one VLAN, same VLAN, right? Bridge the traffic. In another case, when it is two different VLANs, but you have SVIs at both sides, right? SVI at both sides. What you will do is you will send the packet to gateway, route the packet into another VLAN SVI, and forward it, bridge it to the host, right? So this is asymmetric. This one is asymmetric, where we have both the SVI present, correct? But the third case, right? Let's say we don't have this SVI here and we don't have SVI here. Okay. We have only one SVI here and one SVI 200 here. Then what will, so this is symmetric case, right? Symmetric. So now how traffic will be forwarded? So H1 will send the packet to the gateway, right? Now you have common VRF. You have common VRF, this blue, right? And also associated dynamic VLAN with this and VNI 111. So you will check that once this packet reaches to the gateway, it will check the destination IP, right? Destination IP VLAN, and you will have route for that destination VLAN, and that will tell you that send this packet over this VNI or using this VRF to this VTAP2 IP address. So you will route the packet into this VNI, right? Or VLAN, dynamic VLAN, forward the packet through this blue, right? Again, route the packet into this VLAN 200 and then forward it to the host in this VLAN, right? So basically, depending on your configuration, right, you will choose to use that particular, VNI to forward the packet, right? Is it clear? Any question on this? So if VLAN 200, you will choose send the packet through using VNI 100, right? Direct bridge. If you have both the SVI asymmetric, then you will choose route the packet to VLAN 200 and then bridge. So you will use VNI 200, right? To forward the packet to this guy. And you don't have this too, right? Only single SVI on each VTAP. Then you will use common VRF, and through that VNI, you will forward the traffic, okay, to the host. Does this make sense or is it clear?
Yeah.
Yeah,
Oh.
it's there. Hey, Vishal, did you say that sometimes you could have VTAPs that have like VTAP 1 has 100, 200, VTAP 2 has 300 and
Yeah.
200, and then VTAP 3 has 200 and 400, or?
Yeah. So basically, it can be mix and match, right? So 1 minute. Let me come back to that slide. Yeah. So there are three possibility, right? Customer or four possibility that customer either use totally asymmetric, right? Asymmetric. What does that mean is you have all the SVIs everywhere. VLAN 100, 200, 300 everywhere, right?
Yeah. Yeah.
300. But some customer might use symmetric where you don't have all the SVIs everywhere. So 100 is here, maybe 200, 300 is here, right? And through this, this VRF, common VRF or VNI, you forward the traffic between one SVI to another SVI. Okay.
So in that case, which one is the common? 100 is.
Yeah, this one,
on
111 IP VRF is common. This blue.
Okay, okay. So we have 200, 300, and then 111 on a dynamic VLAN, which
Yes,
is mapped
this
to VNI
dynamic
111.
Yes.
Yeah, okay.
So you will forward 100 to dynamic VLAN, then pass it on, and from VLAN dynamic VLAN to either 200 or 300, wherever traffic has to go, right? Destination VLAN. Okay. So that is pure symmetric, but there is possibility, right, that you have VLAN 100 and 200 here, right? And here you have 200 and 300, right? So what does that mean? For VLAN 200, which is common, so basically you have asymmetric routing, right? Same VLAN is present everywhere, both sides. Yeah. But VLAN 100 and 300, you have symmetric IRB, right? Symmetric, because VLAN 300 is not present here, 100 is not present here, right? So to forward traffic between same VLAN 200, basically if you want to forward traffic between 100 to 200, what will happen? 100, 200 route and then bridge direct, right? But if you want to send packet from between 100 to 300, you will come to gateway, route into another VLAN, dynamic VLAN 111, right? Or VRF, forward here to dynamic VLAN 111, route into 300 and forward. Correct? So which is symmetric. So basically customer might use symmetric or asymmetric together like this. Right? So it might use asymmetric across all the SVIs, might use symmetric like each VTAP has only one VLAN, or basically I say unique VLANs, SVIs, or a combination of this two, right? Like this.
Mm, mm.
So depending on your, you know, configuration, it will either use asymmetric. If SVI is present, it will directly send using this VNI. Otherwise, it will send using dynamic VNI, right? This VNI.
Mm. So, and so if we have another switch 3, another VTEP 3,
Mhm.
and it has maybe maybe 400, 500, is that
Correct.
possible as well?
Yeah, that is absolutely possible.
So, okay, if it has also, okay, let's actually add 200 there as well.
Mhm.
So when the traffic comes and supposed to go to, from this side, we're supposed to go to 200. Assume we don't have 200 in that VTEP one, just remove 200 there.
Mhm.
So it's supposed to be symmetric. So what will happen? We will come and send the, how will the
Yeah.
traffic go?
Yeah.
Will
So
it go to
again,
both?
so one thing you have to make sure that you have this VNI common to all the VTAPs in symmetric, right? Then only it's possible. So basically you have configuration that is VRF A, VXLAN VRF A, VNI 111. This configuration should be there present on all the VTAPs, right? This should be there on all the VTAPs. Basically what we are saying is at least all these three VTAP has one dynamic VLAN. Let's refer it as a VNI 111, which is common to route this all the other VLANs through it. Okay. So now when you want to communicate 100 to 400 or 200, you will route the packet into this VNI 111, forward it to across to VNI 111 because VNI 111 is also present here, and then forward it to 200 or 400 depending on destination.
Yeah.
Is it
Sorry,
clear?
I don't know if I'm missing something. Is this traffic going to both the two VTEPs or?
If okay, so if you have
it's on
learned the
for VLAN 200.
Mhm.
Yeah.
Yeah.
Or
So
is there another route that's going to differentiate which one goes to VTEP 3 and which one goes to this VTEP 2?
yes, so see that depends on the route you have, right?
Yeah.
How route you have learned, right? So if you have learned so that let's say this 40.40 subnet, right? 40.40.0 subnet /24.
Yeah.
And here your host is, let's say 40.11/32. Okay, 40.40.40.11. So if you have learned the route here, that is 40.40.40.11, right? /32 through VTAP, and it points that, hey, this is in VTAP 3, then it will directly send to this VTAP, right?
Yeah. What about 200 on both 3 and 2? So we have.
Okay. Yes.
Yeah.
So this is good point. Let's say VTAP 2 has VLAN 200, and this guy also has VLAN 200, right?
Yeah.
So basically you will learn here for that two routes, right? So one will be 20. Let's say 20 is the subnet, right? For 200. So 20.20.20.0/24. If you have learned 24 subnet route, it will point to two VTAP 2 and 3, right? Because this SVI will advertise that both, right? But you are also learning host route /32. So let's say you want to communicate with this host in VLAN 200, which is 20.11, right? So how you will learn 20.20.20.11/32, you will learn only through VTAP 2. And obviously out of this two route, it will prefer this, right? Longest prefix match, and it will send packet only to 2. Okay. So that's the reason, right? Why we are learning this as well as this, right? Or why specifically /32 is important, right? In mix
got it.
symmetric asymmetric.
Yeah, got it now. Thanks.
Okay. Any other question?
Vishal, so
Yeah.
this symmetric IRB case, right? Do
Mhm.
we see this generally like when there are two DCs into picture and VLANs do not need to be stressed. Like, or do we see within the same DC as well? Like,
Okay,
symmetric
so
IO?
if see, okay, so uh, possible, that is also possible, right? See, so generally, let's say you have two data center, right? And generally what you have is mostly you will have only some VLANs, say VLAN 100 or 200, which are common in both DCs, right? But there
Yeah.
are other VLANs, less 300, 400, 500, which is here only local to this, right? Because this is so let's say 100 and 200 is are the servers or VMware ESXi, where you want to extend this VLAN across another DC so that that server you can spin up here through vMotion.
Yeah.
Right. But
Yeah.
your local host, right, users, that can be 400 only local to here, this VLAN, right? And here local users can be 800, right? Which you don't want to basically extend that VLAN, right? You can route. So in that case, yes, definitely for different DC, you can have this type of symmetric IRB, or you can say mix of symmetric and asymmetric IRB, right? Yes, that's right. But for a single DC, the customer generally will run asymmetric, right? Where all the SVI, all the VTAP has all the SVI, right? To avoid complexity. But they might, but yeah, if their resources or routers or switches are not that capable enough, then they might go with symmetric IRB. Or even centralized, right? That we'll discuss.
Or maybe like everything is asymmetric and just with the border leaf it is symmetric. Something
Yeah,
like
means
that
mix and match they can do. Yeah, they can do mix and match. But yeah, that's right, that within two different DC, that is possible, that they are running symmetric. Okay. Any other question?
Yeah.
Yeah. But even in this same case, right? Within this, the normal, like the asymmetric, right? Even if we have to communicate between, suppose VLAN 400 subnet over here and VLAN 800 subnet in the DC2, we can still use type 5 EVPN, right?
Yeah, but so when you want to communicate between 400 and 800, right, you have common VNI, right? WRF and VNI, dynamic VLAN, through which you will communicate, right? Right? I'm talking about symmetric.
Yeah, but in the case of asymmetric as well, right? So in that case, we need to use type 5, right? If we have to.
Yeah, we have to use type 5 to route the packet to 800 subnet. That's right.
Okay.
That is also possible.
Hey Vishal, just clarify something again. I'm not sure if we said it already. So the type, so the /24 route, when did we learn it? Is the VTAPs are going to advertise to each other?
Okay.
Once you configure the VAF.
Yes. So in asymmetric, right? Asymmetric, we were not learning type 5 route, right? There was no concept of type 5 route or routing, right? Any update on routing table, right? Asymmetric. It was just on updating the ARP and MAC, right? MAC table, right?
Yeah.
In symmetric, there is update in routing table, right? There is no update in ARP and MAC, right? Because it's all routing through different stuff. So we update routing table. Now we will have in symmetric, we have both type route, type 2 and type 5. Okay. So type 2 will give us populate our routing for /32 and host route, and type 5 will populate full subnet route /24. Okay. Will help us to populate. Yeah. So in case for some host we don't have this or gone, right? We still have this as a backup. Now, how this will be generated? I will show you in configuration that, basically we configure this, right? The way, if you remember, under VLAN WAF, we configure redistribute learn, right? Redistribute learn. So what, as soon as we learn MAC and R, we advertise, right?
Mm.
Similarly, the configuration for this guy, oh man,
So in short, the once you have the configuration, we will generate a type 5 route that is going to, on the end remote VTEP, they're going to use the type 5 route to install a /24 route.
yes.
But once we learn the MAC address of a host, we send the type 2, and then the remote VTEP is going to use the type 2 to update its app and MAC table, but also is going to use that to generate a /32 host route.
You are right. There is some, some basically if and but otherwise it's right.
Oh yeah, we don't
Okay.
need to learn the MAC. We don't learn app and MAC, yeah, anymore.
Yes. So
We
so
just
again,
install
that
the host route, yeah.
if that, okay. So basically when VTEP 1 sends, I think we'll discuss in next session, right? Or
Okay.
we will come to that, but that's a good point, right? And why we are advertising type 5 route, because under WRF customer A or A, we have redistribute connected, right? So all the connected routes will be advertised as type 5 route. But yeah, we'll discuss that. But yeah, that was good point, that why both we have to advertise, right? That we will discuss type 2 as well, right? So we'll discuss that.
I guess that's because so that it doesn't go to the wrong VTEP, right?
Yes. So that
The
is
router
one.
MAC would be different, right?
Yes.
For the
So
LPM match. Okay.
correct. So that is one point, but yeah, there are other
Okay.
things which we'll discuss in next one.
All right. Sure.
Okay. Okay. So any question? Fine then.